Solve by graphing. Y equals negative 1/3 x plus 2, and y equals negative 1/4 x minus 4. Now we're lucky that both of these are given to us in slope-intercept form. If we look at the first equation, y equals negative 1/3 x plus 2, we can see that the slope is negative 1/3, and the y-intercept is going to be at 0, 2. And we can use that to draw the line. We've got a y-intercept of 0, 2. That's our starting point. And the slope is negative 1/3, so that means we go down 1 and to the right 3. Because whenever the slope is negative, we're going down and to the right instead of up and to the right. So down 1 to the right 3. Again, we can go down 1 and to the right 3, down 1 to the right 3, down 1 to the right 3. We can also go in the opposite direction, moving up 1 and to the left 3. Up 1 and to the left 3. Up 1 and to the left 3, etc., etc. And we end up with our line that looks something like this. Good. Now let's move on to the other equation. The other equation's also in slope-intercept form. Y equals negative 1/3 x minus 4. So we can figure out the slope. It's going to be the coefficient and the x. So the slope is negative 1/3. And the y-intercept is the constant term. That's going to be negative 4. So that gives us 0, negative 4. We can plot the y-intercept first. It's going to be negative 4 on the y-axis. And then we use the slope to get more points. The slope, again, is negative 1/3. So that means we're going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. And in the other direction, to get more points, we can go up 1 and to the left 3. Up 1 to the left 3, up 1 to the left 3, up 1 to the left 3. And if we connect these dots to get a straight line, it's going to look something like this. Now, if you look at these two lines, we're looking to see where they intersect. And at first glance, we don't see any points where they intersect. So we have to think, are these going to intersect each other further away? If we were to continue these lines further out, are they going to intersect anywhere? And the answer in this case is no, they're not going to intersect anywhere. And that's because these are parallel lines. Whenever we have parallel lines, we know that they won't intersect. And we can verify that they're parallel because parallel lines have the same slope, and each of these has a slope of negative 1/3. So we're not just eyeballing it and saying, oh, they look like they're almost parallel. We can tell for certain that they're parallel by comparing their slopes. Now, what does this mean for the solution? Well, we're looking for a solution to both of the equations, which means we're looking for a point that's on both of the lines. If the lines are parallel, then there aren't going to be any points that fall on both of the lines. There are going to be no intersection points, and what that means for us is that there is no solution. Anytime we're solving a system of equations and the two lines are parallel, that means that they will not intersect and there is no solution. So we can say there is no solution. You might also see this situation referred to as inconsistent. That's something that some books use. You might see in WebAssign. My preference is for no solution, because when we're asked what is the solution, I think the proper response is there is no solution. But saying that they're inconsistent is kind of an equivalent thing to say, and that's also allowed.